Hi everybody, this is part 2 of the walkthrough of chapter 3. This is 3.1 to 3.2 more practice worksheet. So I'm going to go through the part that I didn't cover in the first video. So let's start with number 1. The directions say rewrite each degree measure in radians and each radian measure in degrees. So if I start with number 1, and I recall that 180 degrees is equal to pi radians, what I can do is make a fraction, and I want to get rid of the radians. I can tell this is radians because it has a pi in it, first of all, and secondly, there's no degree symbol, so that indicates that this is a radian. In order to get rid of the radians, I'm going to put the pi in the denominator, and I'm going to put the 180 at the top. So just to make life easier, I can go ahead and cross out the pi's. And what I'm going to be doing is taking 180 and dividing by 4. So I'm going to type that in, and you can see that I get 45 degrees. So this would be a 45-degree angle. Number 2 is 225 degrees. This time I'm trying to get rid of degrees. So that means I put 180 in the denominator. That always matches with pi in radians. In these answers, you want to leave pi in the answer. So I'm not going to put 225 times pi divided by 180. Instead, what I'm doing is I'm just reducing 225 and 180. If you want to multiply it out and write it like this before you simplify, that would be okay as well. So now I need to simplify the 225 divided by 180 degrees. Notice I didn't put pi into the calculator, so I'm going to hit enter, and then I can hit math enter enter to simplify this fraction. You can simplify this without a calculator, it just takes a little more time, but this would reduce to 5/4. And don't forget about the pi, so put the pi in your answer. So the answer is 5 pi over 4. For this section, we're following the same directions that we saw at the top. Number 5 says rewrite in radians and radians in degrees. Okay, so this is 330 degrees. So we want to get rid of the degrees. So the 180 goes at the bottom. This means you have 330 pi over 180. Again, I'm going to reduce the 330 degrees and the 180 degrees. Notice I'm not putting the pi into the calculator. I want to have pi in my answer here. So then this works out to be 11/6. So 11 pi over 6. Number 6 is a radian. So that means we're going to put the pi in the denominator and the 180 at the top. The pi's will cross out, and you can multiply 5 times 180, hit enter, and then divide by 6. And then I'm going to divide by 6 here. And I get 150 degrees. Even though this next one is kind of squished together here, this does say negative pi over 3. So be careful when you are typing this answer in. You are going to get a negative answer. We're trying to get rid of the pi. That's the radians, 180. The pi's cross out. So you have negative 180 divided by 3. Some of you may know that that's 60. If you need to, you can use the calculator. You can see that I typed it in here, and it definitely equals negative 60 degrees. The questions that I'm skipping are found on the day 1 video. Look at number 9. We're going to get rid of degrees, so put the 180 degrees at the bottom in the denominator, pi at the top. If you are doing this without a calculator, you can use techniques like this. The zeros would cross out, and you're left with 19/18. If you want to use the calculator to verify that, you can. Otherwise, it's going to be 19 pi over 18. Okay, same deal with this one. I put the pi in the 180 degrees. The degrees cross out. Again, you can use a calculator to reduce this, but another quick technique is if they end in zeros, you can divide out the zeros. That's like dividing by 10. And then negative 5/18 doesn't reduce anymore, so negative 5 pi over 18. If you need to use the calculator, that is perfectly fine as well. Some of these can be done kind of mental math with mental math, so if you want to practice that, this would be a good opportunity. Number 12 says a paddle wheel of a riverboat has a diameter of 24 feet. Find the arc length of the circle made when the paddle wheel rotates 300 degrees. Arc length is represented by this formula. That's S is the arc length, R is the radius, and theta is the angle in radians. In this question, you are given the diameter of a circle. A diameter of a circle goes all the way across. So if this is 24 feet all the way across, if we need the radius, we just need to divide that by 2. So 24 divided by 2 is 12, so we have a radius of 12 feet. Theta is also in the wrong form. You are given theta is 300 degrees. Just like we've done in previous questions, if you need to get rid of the degrees, you can divide by 180 and multiply by pi. That would take care of these degrees, and you could reduce this if you want to. However, I'm going to be typing this into this example anyways, so I can just write that entire angle. So I'm just going to put the 300 pi over 180. This time I am going to give my answer as a decimal, so I can multiply in my calculator 12 times 300 times pi. I'm going to hit enter, and then I'm going to divide by 180. And I get 62.8. I'm going to round to the tenths place, so 62.8, and I believe this is feet this time. So yes, 62.8 feet. 13, a circle has a diameter of 9 centimeters. Find the arc length if the central angle is 60 degrees. Round to the nearest tenth. Same formula, S equals R theta. So I wrote down the 9 centimeters. I need half of that. So take 9 divided by 2, and that gives you 4.5. So the radius will be 4.5 centimeters. And to find the angle, I'm going to take the given information, which is 60 degrees, and just like we've been doing with all the others, we need to divide by 180 and multiply by pi. That takes care of the degrees. You could reduce this if you want, and I believe it actually ends up being pi over 3, but since I'm going to put it into the calculator anyways, I'm just going to write 60 pi over 180 in my parentheses. So far I've typed in everything in the numerator, I hit enter, and then I'm going to divide by 180. You can see that I get about 4.7, and in this case, we were talking about centimeters. So the arc length is about 4.7 centimeters. So now you should be flipping the paper over, and we're going to look at those 2 questions at the top. These are just general finding the arc length formulas. So again, these are going to be S equals R theta. In this example, you were given both the radius and the angle in radians, so you can just plug it into the equation. The directions do say to round to the nearest tenth, so I typed in the 5 times 3 times pi, and then I'm about to divide by 7. So remember to hit enter after you type in that numerator. So I'm going to hit enter, and it says to the nearest tenth, so I'm going to round it to 6.7 centimeters. Same thing goes with this one. You can see that you have the arc or the radius given 27 meters, and you have the angle, and it's also in radians. So go ahead and just plug it in and then calculate in your calculator. You can see I typed in everything in the numerator, hit enter, and then I'm going to divide by 9. So this one ends up being 94.2 meters, 94.2 meters. Number 18 is an application problem, and it's asking several different things about an angle of a swing. So we have a swing, it has 165 degrees of rotation. First question, draw the angle in standard position. So I'm going to draw an X and Y axis, just a simple one. 165 degrees starts here at 0, rotates up 90, and doesn't go quite all the way to 180. So it would be somewhere in here. This would be 165 degrees. Letter B is just asking you to write that angle measure in radians. We've done a bunch of these. So I just set it up like this. I'm going to put the 180 degrees in the denominator. That's the degrees, and the pi at the top. And what I'm going to do now is reduce this fraction. I'm not going to put the pi in the calculator. Anytime it's asking me to write a measure in radians and it doesn't specifically say decimal, then I know I'm going to reduce it without the pi. So don't put pi in your calculator. So you should see that I reduced it and I ended up with 11 over 12. So this would be 11 pi over 12. Okay, so now take a look at letter C. If the chains are 6.5 feet long, what is the length of the arc that the swing makes? Round to the nearest tenth. So that's going to be arc length, S equals R theta. So for radius, instead of 6.5, I'm going to put in 6.5, and the angle is 165 degrees, which we just converted to radians. It's 11 pi over 12. So we just need to plug in the 6.5 for the radius and plug in the 11 pi over 12 for theta. The directions for this part C does say to round to the nearest tenth. So I typed it all into my calculator and I ended up with 18.7 for that length, and this would be feet. So letter D sounds complicated, but it's just asking you, how would the arc length change? So how would this answer change if we double the lengths of the chains of the swing? Well, the swing chains are 6.5 feet long. So if we double that, 6.5 times 2, that would be 13 feet. So 6.5 times 2 would be 13 feet. So let's see what would happen if we have double the length of the chains. We would still have that same angle. And go ahead and type this one into your calculator. So you can see what happens is I end up with 37.43. If you double the length of the chains, then what you see happening is that the arc length doubles as well. So this is about double what we had originally. So you can say that the arcs are doubled as well, or the arc length doubles. The last three say to find the area of the sector of the circle. They give you the radius and the theta, and we have to find the area to the nearest tenth. So you can see that I replaced 1/2 with 0.5 because I'm going to be typing this into the calculator. I'm going to put in the 87.9 in place of the radius. Don't forget you've got to square it. And then I'm going to put the pi over 8 in for theta. So I typed in the 0.5 times 87.9 squared times pi like this. I'm going to hit enter. And then I'm going to divide by the 8. And I get 1,517.1. Your label for this would be square centimeters or just centimeters squared. This example gives you a little bit different information, so let's see what's given. Find the measure of a central angle, because that means we're finding theta. You are given the area is 59 square inches, so that means I'm going to put in the area here. We know that 1/2 can be rewritten as 0.5, and the radius is given, it's 7 inches. So what we're finding is theta. Okay, so we need to do some simplifying. 7 squared is 49, and what you're finding here is 1/2 of 49. So I did 1/2 of 49, or 0.5 times 49, and I got 24.5. My last step here is to get theta by itself. I'm going to divide by 24.5 on each side. And you can see that it says to round to the nearest hundredth in this question. So I'm rounding this to 2.41. Hundredths is 2 numbers after the decimal, 2.41. In this formula, theta is an angle, and in this case, theta is in radians. If you needed the answer in degrees, then you would have to convert it at the end. This one was just looking for radians, so you're done. Last question is asking for the area of the field if the central angle is 49 degrees and the radius is 117 meters. So let's plug in what we know. We're rounding it to the nearest whole number, so no decimals on this one. So I changed this 1/2 to 0.5. I put in the 117 squared for the radius, but theta is a problem because they give you theta in degrees. So remember, we have to first change it to radians. Okay, so I converted it to radians, and then I typed it into my calculator, 0.5 times 117 squared times 49 times pi, hit enter, divide by 180, and I ended up with 5,853.49 and so on. It says to round to the nearest whole number. Since this is a 4 behind this decimal point here, I would just round it to 5,853. And this would be meters squared or square meters since it's an area. Have a great day.